Well, like I say, that this is going to be talking about building a data analytics foundation, kind of key off of what David's keynote was this morning about taking our data and then being able to present it in a useful manner to make decisions, business, or how we want to move out of as a company, how to do that. The presentation is based on Microsoft SQL Server. It can be built with other platforms underneath it, but we're going to focus on Microsoft SQL Server today. We're going to be talking about the Microsoft Data Platform, how to visualize and decide, transform and analyze, and then collect and manage your data, and how to set up the systems to do that with. Please, anybody, if you have a question, like they said earlier, just post the question, and we'll try to answer those as we go. So we're going to use SQL Server 2017 as the topic of this. We're going to be bouncing a little bit with some new compatibilities of SQL Server 2019 when they come about, but we're seeing a slow implementation of SQL 2019. So we wanted to keep the presentation to a version that seems to be really being implemented across the spectrum. SQL Server 2017 is an industry leader in performance. It now runs on several versions of Linux. It'll also run in Docker. Common languages across those platforms. It also has built-in Python support starting in 2017, which we're seeing a lot of people converting their R code to Python to move forward with. The evolution of SQL Server and how it's grown is the industry has been pushing for open source OSs and data platforms for a long time, and they're becoming more prevalent, and there's a lot more flavors of them. So Microsoft made a decision to get SQL Server running on some Linux platforms, and then when Docker rolled out a few years ago and started becoming a real big player in the market, they've moved out to let SQL Server support Docker containers. Have multiple data types that are good, so you have a wide range of data. It can be built on-prem, in the cloud, just about any cloud vendor if you use infrastructure as a service, and also a lot of different cloud vendors also provide built-in templates with SQL Server pre-installed on them. So you're renting your license instead of having to buy the license of SQL Server. Or you can set it up in a hybrid environment where you're using both on-prem and the cloud. Some of the things that Microsoft has done because of choice is adding HD Insight on Linux, R Server, Linux and Azure, beefing up the drivers and connectivity to SQL Server, and also extending it to Visual Studio for a lot of the SQL Server code store and stuff. Like it says, Linux is becoming a very big player in the market, and so that's why Microsoft moved that way. We have several clients. We also do a lot of testing on the Linux version of SQL Server. If you're going to run a pure SQL data store, you might want to look at the Linux implementation. It is incredibly fast, running the behind-the-scenes SQL Server. We're going to discuss two possible build-out scenarios. And like I say, we're going to, if we host it on multiple platforms, multiple clouds, we're going to use Azure as our reference because that's where we're seeing a lot of implementation of this because it is a Microsoft platform, Microsoft's cloud running Microsoft technologies and systems. We can set up on-prem SQL Server, and then you're running SSIS, and you can, of course, have R and Python running locally with machine learning server that's built into SQL Server. Or we can go to the cloud and have disparate sources running with Data Factory. We can connect into an Azure data lake for very quick access to lots of different types of data. And then we also run that into either a SQL data warehouse, SQL Server database in the cloud, or we can actually run it to infrastructure as a service. Like I said, if you have any questions, please stop me, and I'll answer those as they come through. Some of the architectural options that we have with the SQL Server platform is we can go 100% on-prem, which lets you as a customer manage everything from the OS, the VM, structure, storage. Everything is managed on-prem by your staff or by contract staff. We have the Azure offering of infrastructure as a service, a way it simplifies management, as in that you only have to manage your image, your OS, your applications, and your data. The Microsoft manages the underneath, the visualization, the servers, the storage. They take care of all the networking and everything behind the scenes of that infrastructure as a service, or VMs on Azure. Or you can go with platform as a service, which is also referred to sometimes as database as a service. That's where the only thing you worry about is the application and the data that you're worrying. Microsoft takes care of managing everything else related to the system. Some of the Azure solution paths, infrastructure as a service, that's where you stand up a VM on Microsoft's backbone and Microsoft's equipment, and that's the VM that you manage. You control the OS, you patch it. Microsoft doesn't do anything except the underpinnings of managing storage and the actual virtualization hosts. Or we can go platform as a service as a Azure SQL database, or you can also go a SQL data warehouse. With the infrastructure as a service, you have full control and you have the flexibility that you would have as with an on-prem system, except it's hosted on Microsoft data center. If you go with platform as a service, you simplify your administration. Microsoft is taking care of all the virtualization, patching, everything under the covers. We see a mixture of both solutions being put into place. Nothing is prevalent over the other. There are just some things that we would, if you're thinking about doing this, contact Synergy. We can go through and find out your requirements and then kind of work with you as to what would be the best fit up front, so that you don't go into something as a trial and error and wind up having to tear down and refit to another system, or you get a bad taste in your mouth for the Azure platform, and we don't want that to happen. So the on-prem solution that we're going to talk about is using SQL Server's built-in capabilities. And these are coming from disparate sources, flat files, other database platforms, MySQL, Oracle, Progress, PostgreSQL, Cosmos, any of those other database platforms. You can also pull from software as a service providers, Dynamics for Microsoft, cloud-based Epicor, cloud-based NetSuite, any of those cloud-based services. And by using SQL Server integration services to bring that data out, to extract it from those sources, transform it, and bring it into a SQL Server database. You can also then use from your SQL database or your online data store, or ODS. You can use SQL Server's integration services to transform that data and move it into a data warehouse or data marts, whichever methodology you choose that would best fit your business. You can also use machine learning and use R and Python to pull directly from sources, including the SQL Server database, your online data store, and then use R to push that into your warehouse or marts, or R can visualize it straight to your consumer sources, analytic services, reporting services, or Power BI, Excel, etc., from the user's desktops. In database analytics with SQL Server, in 2016, SQL Server, they launched 2 platforms integrated with the R language for business applications. They used R services, which was an in-database integration of R that you can query straight from T-SQL. And then they also included an R server, a standalone R server, where you could run enterprise level deployments on Windows and Linux servers. Starting in 2017, they changed the name from R server to machine learning, and they also brought in support for the Python language, which is, like I said, is becoming very popular, and we're seeing a lot of conversions from the R language into Python. Machine learning services are in database, so you can install them as part of the database and then run your Python or R straight in the database from your T-SQL code. Or you can stand up an actual standalone machine learning server and then using a Python language or a GUI interface like Anaconda or Spider or something like that to build your Python scripts and deploy them and schedule them to run through the machine learning server. We're seeing that adopted a lot. They want to be able to separate the Python and the very high level analytics and powerful analytics on a separate server so they can feed it resources separately. If they need more memory, it's not going to starve the SQL Server, and you can get that processing outside of the box. Machine learning services built into SQL Server. It has a very elaborate or very extensive analytics library. You have the languages, analytic languages of R and Python. And then we have relational databases underneath it that you can have the T-SQL language. Like I say, you can run your heavy analytics from external from the machine learning server, or you can run it internal if you install it with the SQL Server and it becomes in-database analytics. We're seeing a lot of use by the data scientists. They use it to publish algorithms, interact with the data. We've got one client that uses Python extensively to bring all their data into their data warehouse and data analytics platforms. Your business analyst, we also see that group of people also getting into the R languages and the Python languages to do their in-depth analytics. Some of the benefits is you don't have to move your data to work with it. You can work with the data right where it's sitting, and therefore your return times are a lot quicker. You have a lot of real-time analytics on transactional data because it doesn't have to move the data to work with it. And then you can integrate into existing workflows, and you have unified governance across analytics and storage. The Microsoft Azure solution, like I say, disparate sources. We're seeing a lot of people integrate those disparate sources, streaming data included, into a data lake, and then using the data lake and the Azure Data Factory to move the data into their data marts or into their warehouse or SQL databases that are then used to connect by your consumer sources, Power BI, dashboards, et cetera, et cetera. Machine learning and very extensible .NET languages and the different programming languages can reach into the data lake to pull data directly, so it doesn't have to be loaded into a relational platform before it's used or consumed, which speeds time of delivery of the data drastically. Talk about the Microsoft Azure Data Lake. The data lake includes a lot of capabilities. We're seeing a lot of usage by data scientists especially because it has the capability to store so much data, and it makes it so much faster to get and to use because we don't have to munge it and transform it first. We can pull it, load it, transform it, report it without ever having it touch an actual platform to rest any, to speed things up. We're seeing it working with existing IT investments. It works just great with integrations into the operational data stores, the data warehouses. It consists of two basic components: the data lake store, which, like I said, removes the complexities of ingesting and storing your data, and then the Azure Data Lake Analytics, which is a cloud analytics service that is used and You pay for it per job as it runs, but like I say, it is extremely quick. You can sort through petabytes of data in just almost the blink of an eye. It's super fast. But it has to be planned. It has to be set up correctly. Like I say, if you want to research or go look at the data lake implementation, reach out to Synergy, reach out to us, so that we can talk about what the need is and try to design it before we implement it, so we don't run into a lot of those roadblocks that we've seen people run into the past, and then they get to the point where they just throw their hands up and walk away from it. When if with a little planning, it could become a great asset for the company. How the data lake works, you take your on-prem data, your different data streams, using Data Factory, you load that data into your data lake, and then you have the freedom there to analyze it right there in the lake straight from it, or you have the ability to use Data Factory to push it into your data warehouses or your data marts, and then they can connect to consumers. Web portals can all be connected directly to the data lake to expose data, or you can have a layer of security and objects there where you can control what they're seeing, how much they're pulling, and try to control the cost of jobs as they run through. The Azure Data Lake store, there's no limits. We just have petabyte-sized files, trillions of objects. It's scalable for massive parallel analytics. You have HDFS on the cloud. It's always encrypted. You have role-based security and auditing, and they do have enterprise-grade support behind it. So if you have any problems, you've got support right there when you need it. The data lake starts in seconds. It scales instantly. You pay per job. You can develop massive parallel programs. You debug, optimize your big data programs, visualize your analytics, and of course, there's enterprise-grade support and security over the data lake, so that you have less security concerns in this modern workplace of cybersecurity. Getting started with machine learning, we'd like to come in with you, do an analytics assessment, find out what you need, find out what you're looking for, what your plans are. Moving forward from there, you can use deployment planning services for the enterprise clients. They have DPS hours that can be used for this analytics and for the planning, and also for proof of concepts. So the Azure data platforms are everywhere, so you can reach them anywhere in the world you're at. So that removes the problem of opening networks up and controlling those networks, because Microsoft takes care of that security and networking for you. And then you can also use customer architecture sessions to help figure out and build exactly what you want. And this one moved a lot quicker than expected because we didn't have the live audience and audience participation and questions flowing. So is there any questions that we have at this point?
There's no questions in the chat at the moment, John. But everyone out there, the floor is open for questions.
Hey, Patrick, this is Ro, and my cat may be getting ready to participate in this conference right now. Bash, you want to say hello to everybody? This is Bash.
Hey, Bashy.
Participating all day. I'm going to throw him out real fast. He's throwing himself out. Thank you to everyone. I know that these sessions are a little bit more, it's difficult to pivot from doing something that you intended to do live to doing something virtually. So from a speaker perspective, it can be a little bit challenging because you don't get the interaction with audience members that you normally would when you're speaking to a live audience. So just recognize that. we knew we were going to have some bumps along the way. We actually had very few bumps for something that we had to pull together, in a period of just a couple of days. So personally, I'm pretty pleased. I know we had some challenges getting this session started, but we didn't have any epic disasters, I would say. I know that Patrick did mention at the beginning of the session when we were getting the audio fixed that we were going to email out the winners for the sessions, and we'll do that likely tomorrow morning. So look for an email from Christina Caesar. She will announce it. We'll make all the session recordings available online. We do need to do some editing and just make sure that we don't have any PII that is inadvertently getting posted, because we certainly do not want that to happen. So that may take us a day or so. We'll make sure that you get all the session decks, and we'll make sure that we get any questions addressed that were posted in the sessions. So with that, I think we're pretty much at a wrap for this session, unless anyone has any specific questions that we need to get answered. And John, I do appreciate that you jumped on and kind of had to divert pretty quickly into how you intended to present. So challenging.
Hey, you see the Marine Corps flag flying behind me. Improvise, adapt, and overcome.
And that is what we are all doing right now. That literally summarizes the situation that everyone is in right now. So I think that's it. Let me just see if we've got any chat questions going on. I think we're in pretty good shape. All right, so I think we're going to call it a wrap, and we'll get everybody the information that you need over the next 24 hours or so.
All right, thanks everyone.
Thank you.
Thanks, guys.
Thank you.
Thanks, everybody.
Bye, guys.
Bye.